Hey, this is Mr. Hansen. This is the second part of a two-part series on congruent shapes. In the first part, we discussed how we can use transformations to prove that two shapes are congruent. More or less, we are just moving the two shapes around so one is right on top of the other, and if you can show that they are the exact same shape, you know that they're congruent. We worked with translations and reflections, so let's start with the reflection problem here. I've got a triangle ABC on the bottom part of this grid, and you might recognize that's a reflection, and so you could have something like this: x, y is going to change to negative x, y. So in other words, this x that was -1 will change to -1, which is +1 there. Okay, what I'd like to do from here is write a congruency statement. We didn't go over this in the last section, so I think this is really important. And the idea is you start with your first triangle. It's called your pre-image. So triangle ABC, and you can write that triangle any way you want to. I could have written it triangle BAC, it doesn't matter, or CBA, it doesn't really matter. But if I write it ABC, then I'm going to write it's congruent to triangle, and notice the congruent symbol is an equal sign with a little squiggly on top. If we start with A is going to reflect over to A prime, so it corresponds to A prime. And B is going to correspond to B prime. And C is going to correspond to C prime. So their positioning is the same. So this point here is going to move to that point there, and B is going to move to B prime, and C is going to move to C prime, and so on. This helps you also when you're identifying line segments. Line segment AB right here is going to correspond to line segment AB. And line segment BC, the second and third letter right here, is going to correspond to BC prime right there, the second and third one. And finally AC right here is going to correspond to A prime, C prime there. Okay. Now, if we'd written it as triangle BAC, we could rewrite the second one like this: B prime, A prime, C prime. And it tells you the same thing. So basically, each of these points have to correspond to each of those points there for it to be a correct congruency statement. All right, let's take a look at rotation. We haven't discussed this as much yet, haven't discussed this at all yet. We've just done reflection and translation. Rotation is when you take a point and you I like to think of it as a kind of a string here, and you're just kind of swinging that point A in a circle. So it comes right here, and that's kind of a 90-degree swing. You can kind of see if you make those lines that that's 90 degrees there. It's a quarter of a circle. So we're swinging 90 degrees counterclockwise, and maybe you can see B, if you're doing the same thing, what's it going to go to, T or X? And hopefully you're realizing that it's going to go to T. And again, you have like kind of a 90-degree angle there, and then C would go to X. Okay, so this is kind of messy, and I apologize for this, but let's just look at B and T for a second. If B is 3, 1, and T is -1, 3, do you think we could write a function rule that would give directions to all the other points on triangle ABC to get it to that other triangle? So let's try this. X, Y, and can you see how the X and the Y have switched places? Basically, if you think about it, your horizontal has become your vertical. Kind of think about it that way, maybe. So X and Y switch places, and the Y that was positive has become negative. So it's -y, X, and this should work for every other point on the triangle. Now let's make a congruency statement. We've got triangle ABC is congruent to triangle. We know we know that A matches to R, so I'm going to go triangle R, and B matches to T, and so that would leave C to match to X there, RTX. And there's your congruency statement. And here is your rule that's 90 degrees counterclockwise about the origin, about that point right there. So that's kind of our rule, is we've turned it 90 degrees counterclockwise. Okay, let's take a look at this second one on the right side. So this time we're taking B and we're turning it so that it's going to be on C. So you can kind of see if you attached a string here and you kind of turned it like that, it's at a 90-degree angle. So B to C, and maybe you can see the same thing. A is going to go to R right there, and then C is going to go to N. So just kind of think of that whole thing just turning 90 degrees about this point right here. And let's see what happens in terms of a coordinate notation rule. If A is 1, 4, so A is 1, 4, and R is 4, -1, let's write a rule, x comma y. You can see x and y switched, and x became negative there. So 1, 4 to 4, -1. And this is a 90 degrees, this is a 90 degrees clockwise rotation. Let's do this. Let's write a congruency statement. So triangle ABC is congruent to, well, we know A goes to R and B goes to L. I think that was L there. And then C would have to go to N, R, L, N. So AB, segment AB, is the same thing as segment RL there. And segment BC is the same thing as LN there. And segment AC is the same thing as first and last, same thing as RN. Okay, one last one. This takes a combination of both of the ones we just did. So I could kind of draw that last one we just did like this. So we're turning ABC, we're turning it clockwise 90, and then if we turned it clockwise another 90, you can see it lands right there on that last triangle. So if we go 90 degrees plus 90 degrees, it's a 180 degree rotation. And the interesting thing about this is it doesn't matter if we go clockwise or counterclockwise. If we go 180, it's kind of opposite, so it works out. So it's a 180 degree rotation, and let's just do the coordinate notation, so x, y. And here 1, 4. A is 1, 4. Well, if we went from there to here, right there we have a 4, -1. And if we went from there to there, we have -1, -4. So we started at 1, 4, and we went to -1, -4. This dot to that dot to that dot. So xy to negative x, -y. And that's a 180 degree rotation. You might recognize this as being two reflections as well. It's a reflection over the x and over the y-axis. That would work just as well. Okay, now for the final thing. Here we have two things going on. We have to put ABC onto the other triangle. So prove that triangle ABC is congruent to triangle, let's see, RLM. Prove that that's congruent to triangle RLM. Can we prove those two triangles are congruent? Well, first of all, they're not going, the orientation's mixed up a little bit here. B is shooting off to the right, and I think that would correspond to L. It's shooting off to the left. So I'm going to kind of fix that by doing a reflection. I'm going to put a triangle right here, and maybe you can kind of see, I'm just going to call this B prime for the moment, and A prime and C prime there. Okay, so we did a reflection, and then maybe you can see from the reflection, if we just move that A prime down to R right there and B prime down to L, we're translating it down too. Okay, so all you have to do is reflect triangle ABC over the y-axis, then translate down 2. And you would get that ABC would be right on top of RLM, and you've proven it. Okay, let's try one more. Okay, let's call this one ABC here. And let's call this OTRY. So I'm kind of thinking, this one's a little tougher, but I can kind of see this RT and AC are probably supposed to line up with each other. And right now we're to get from C to A, we're kind of rising 2 and running back 1. And here we're rising 1 and running 2. That's telling me, okay, it's probably a 90-degree rotation. We're kind of flipping that rise-run situation over. So I want to try and make a 90-degree. So first of all, if I'm going from B, maybe I could make another line segment, and my new B would be right there. Okay, that's 90 degrees. And if you kind of thought about C, and maybe I want to show you another way to think about this. Think of it as a hook a little bit. If we took this hook and latched it onto B, and then we just turn that hook, it would turn right to there. So we're just kind of turning that hook 90 degrees there. Okay. So if we went over 1 and up 1, we're going up 1 and over 1 now. So let's try that for C. We're going over 1, 2, 3, 4, 5, and up 2. Let's go up 1, 2, 3, 4, 5, and back 2. So there's like my new C. I'll call that C prime. Okay. This was my new B. I'll call it B prime. And for A, I'm going over 1, 2, 3, 4, and up 1, 2, 3, 4. So let's go up 1, 2, 3, 4, and back 1, 2, 3, 4 right there. So there's my 90-degree rotation, kind of like that. And now from there, can you kind of see what needs to be done next? Hopefully recognizing that you just have to slide it down 1, slide it down 1, slide it down 1. And there you are. So we've just proven that the two triangles are congruent by rotating 90 degrees, then sliding down or translating down 1 unit. So this is the kind of stuff that it gets kind of fun. I hope this is helpful to you. I just want to review real quickly. We talked about congruent shapes, or shapes that have the same shape and size. And then we talked a little bit about, in this video, we talked a little bit about congruency statements, and we've discussed coordinate notation in some depth in these last 2 videos. And so in this last video, we did a lot with rotations, 90-degree rotations, clockwise or counterclockwise. And then we put 2 shapes on a coordinate plane, and we were going to try and get one shape to get right on top of the other. If we could do that, we'd know that they're congruent. So we were kind of proving 2 shapes congruent using transformations. Thank you so much for listening to me. I know this is it seems like a lot of information, but as you practice some of these practice problems that would be kind of like this, you'll get really good at it. And keep up the good work. Thanks. Have a good day. This is Mr. Hansen signing out.